Hi, I'm Tomer Nahumi from Dell EMC. This video will show the steps involved in deploying a fully functional Tanzu Kubernetes Grid cluster via vSphere with Kubernetes and Dell EMC PowerStore vVols. The first thing we need to do is build a storage policy in vSphere. This can be referenced by the Kubernetes storage class manifest. To create a new storage policy, go to the VM storage policy page in vSphere and click Create VM Storage Policy. Here, provide it a name and click Next. Then, check the box to enable rules for Dell EMC PowerStore vVols storage. These rules are automatically created during the PowerStore VASA registration. Here, select the QoS priority. PowerStore QoS priority rule determines the relative performance prioritization for the VM if the system experiences resource contention. Here, you can see that our vVols data store is compatible with the storage policy. Now, let's click Next and finish. PowerStore vVols leverage storage policy-based management to ensure VMs have the appropriate storage capabilities through their entire lifecycle. VM storage policies can be optionally created after a storage provider is registered. These policies are used to determine the desired storage capabilities when a new VM is being provisioned. At this point, we are now ready to create a new namespace in order to deploy Tanzu Kubernetes Grid cluster. We navigate to our WCP cluster and click on the Namespace tab. Here, we click on Create a new namespace. We select our WCP cluster and specify the name, and then just click Create. We can see that the namespace creation completed successfully and the Kubernetes status is active. At this point, I'm adding the Dell EMC PowerStore storage policy I just created to our namespace. This will allow me to create the TKG persistent volumes on my Dell EMC PowerStore vVols data store. Next, I'm logging in to my vSphere Kubernetes using the kubectl command. I'm authenticating with the administrator at vSphere local user. Then, I'm switching to the new namespace I just created using the kubectl config useContext command. By running kubectl get-sc, we can see the PowerStore policy. This appears as a storage class within the namespace. As you can see, I'm using this storage class in my manifest file of my TKG cluster. This storage class is used for both the control plane and the worker nodes. You can also see the namespace and the TKG name. Now, I'm just going to create it, so now we can go back to the vSphere UI and see what's actually happening in our namespace. We can see that a new TKG cluster has been created and the control plane VM has been built out but hasn't been powered on yet. I will speed things a little bit as this process takes about 10 minutes to complete. By navigating to NSXT, we can see that a Tier 1 gateway is being created for the namespace, as well as a new load balancer. Now, let's connect to our PowerStore cluster and navigate to the vVols tab. Here, you can see that we have multiple vVols, and each of them belongs to a particular TKG VM. The type of vVols provisioned depends on the type of data that is being stored. Config vVol stored standard VM configuration data such as VMX, log, and NVROM files. Data vVols store data such as VM decays, snapshots, and clones. Swap vVol stores a copy of the VM memory pages when the VM is powered on. Now, let's log in to the guest TKG cluster I just created by specifying the Tanzu Kubernetes cluster name and namespace. We can also take a look at the nodes to make sure we are in the right context. Here, we can see the single control plane node and the 3 worker nodes. Now, let's create a stateful application inside the TKG cluster. For the purpose of this demo, I'm deploying an application called YugabyteDB, which consists of 3 master nodes and 3 worker nodes. Each has a persistent volume claim, which will represent a single virtual volume. We can see that within a few seconds, all pods are up and running. We can access the application UI by navigating to the service address and specify the application port. Persistent storage is presented through the VMware CSI driver called CNS. CNS uses existing storage options for storage provisioning in a new way. First, it is based on storage policies, as we saw before, and furthermore, it uses first-class disks instead of standard disks. FCDs are just virtual disks, but in the API, they are first-class objects, which means that they can be created and exist independently of a virtual machine, which makes sense for something like a container. FCDs can be created, snapshotted, resized, etc., just like a virtual disk, but without a virtual machine to own it. This is exactly what Kubernetes persistent volume claim is. Dell EMC PowerStore vVols integration is a key component of this solution, as it offers full flexibility and granularity that may be required by your containerized applications. You can define multiple VM storage policies, which can be assigned to different storage classes within Kubernetes to really fit your needs. I hope you will find this demo useful, and thank you very much for watching.